All right, so getting a few questions on how to calculate head pressure. And so we're going to talk about static head pressure, which is the weight of the oil in the reservoir with gravity acting on it. And so the easiest way for us to understand this is to start with just a cubic foot of oil. So we're just going to draw a simple cube so we sort of see what I'm talking about. Very bad, poorly drawn cube, no problem. So we're going to say a cubic foot, 1 cubic foot of water, H2O, equals 62.43 pounds, and that is with a specific gravity of 1.0. When we have that cubic foot of oil, what it's actually sitting on is 1 square foot of area. And so then, if we use Pascal's law with the trades triangle here, force, pressure, area, our force is the 62.43 pounds, and our area it's going to be acting on is actually 12 times 12. That's 1 square foot, or otherwise 144 inches squared. All right, so then our pressure then by that oil of 1 cubic foot acting on each individual square inch is simply 0.43 psi. And that's with a specific gravity of 1.0. Now, if we assume oil has a specific gravity of 0.8, then we can simply calculate the same head pressure by using that vertical foot of oil. We just modify the 0.43. We would say 0.43 times 0.8, and we would end up with 0.43 times 0.8, and we get 0.344 psi for every vertical foot of oil. And so now, what does that actually mean? Well, if we have a reservoir and it's got a certain amount of oil there, and it's got a pipe coming out of it going into the inlet of a pump. And we would say from the pump inlet to the out port is, let's make up a number, 18 inches. And then from that outlet port all the way up to the top of the oil level is another, let's say 26 inches. Let's just be mean to ourselves. Then what we would actually see is that vertical total from the oil level to the inlet port is actually going to be 26 plus 18. So it's going to be 44 inches. You know, I couldn't have been kinder to myself and just made it 48. Now we had to deal with 44. All right, so we got a 44-inch drop or vertical height, and for every foot of oil it's 0.344 psi. So what we need to do is take this 44 divided by 12 to know how many vertical feet total we have. So 44 divided by 12 is going to be 3.66 repeating vertical feet. And we're simply going to multiply that by 0.344 if it was oil of specific gravity 0.8, and we would say that the vertical head pressure is 1.26 psi. So this is one of the reasons why your pressurized reservoirs only usually have about a 2 psi valve in them, because we don't need that much head pressure, but we do need some. So this is how we would understand how to get a generic, this is a very generic number. For every vertical foot of water, we would say 0.43 psi. You multiply it by the specific gravity of the fluid you're dealing with to understand for every vertical foot of your fluid, and then understanding it with a situation of what does that actually mean for the head pressure acting on the inlet of the pump. Remember, this is static head pressure, not dynamic head pressure. You're going to need to find someone else's video to figure out dynamic head pressure.